Guys, and welcome. In today's video, I'd like us to talk about raw echelon form and Gauss elimination. Okay, so if you have a system of linear equation and you apply raw echelon form and linear operation on it, you are basically trying to transform it to be in a form where you have something like this, where you have something of this nature. Okay, so you're basically transforming it such that you have a diagonal of ones like that. Here you have a diagonal of ones, and below that diagonal you have 3 zeros like that, like this ones. You have 3 zeros. So that is basically what you're trying to accomplish when you're using raw echelon form, when you're transforming your matrix to be in a raw echelon form using linear operations. Okay, basically what we're going to do now is that we are going to use raw operation to transform our matrix to be in this kind of form. Okay, or it can be in a form where you have all zeros at the bottom row. Okay, then it can be something like that. Now here let's put a 1 and then -2, -3. Yeah, or it can be something of this nature where you have all zeros at the bottom, and then on the next row the leading number is 1, like that. Okay, because also on this row the first non-zero number that is leading is going to be 1, like that. Okay, so you can either have it in this form or this form. Okay, so now let's dive into the problems and see how do we obtain such how do we perform operation to obtain this form. Okay, let's suppose we have the following three system of linear equations: x minus 3y plus 2z equals 0, and 2x minus y minus 2z equals -1, and you also have x plus y plus z equals 3. Okay, so in order for us to perform raw echelon form and raw operation, we have to put this system of linear equation in what we call an argument matrix. Okay, so an argument matrix, what we simply do is that we take the coefficients of each equation. So we're gonna put it in there like this. For the first equation, the coefficient is 1, minus 3, 2. Then we're gonna represent an equal sign with a diagonal, with the vertical line like that. Then 0. Okay. Then we have 2 minus 1 minus 2 and -1. So these are the coefficient of the second equation. And on the third equation, we have 1, 1, 1, and 3, like that. Okay, so now we are going to perform the operation such that we obtain zeros on this three numbers here. You want to obtain zeros here and the diagonal of ones there. So the first thing to do is to obtain zeros first. Okay, so now how can we apply the operations in order for us to obtain the raw echelon form that we want? So now the first thing to do, I can say, okay, I can see that it is more easier to find 0 there, since I have 1 and the 1 there. I can make this one to be negative. Okay, so I'm going to apply the operation on row 3. So since I'm applying the operation on row 3, only row 3 is going to change. The other rows are not going to be affected by that operation. Okay, so now I'm going to say row 3 minus row 1. So the new matrix that I'm going to get from that, since we're not changing row 1, we're going to keep it as it is. It was 1 minus 3, 2, and 0. Okay, then the second row, it is also not affected. Is 2 minus 1 minus 2 and -1, like that. So the only one that is going to change is row 3. So this whole row is going to change. We see that how we're going to change row 3 is that we're going to say row 3 minus row 1. So 1 minus 1, that is going to give us a 0 that we want there. That is nice. Then 1 minus -3, that is going to give us a 4. then 1 minus 2, that is going to give us minus 1, and 3 minus 0, that is going to give us a 3 again there. So the next thing that we'll want to do is to obtain another 0 there. So in order for us to obtain another 0 there, we see that we can use row 1, okay? So basically on row 2, the operation that we can apply, we can say minus 2 row 1 plus row 2. So notice that when we multiply row 1 with negative 2, this number here is going to be negative 2. Then negative 2 plus 2, we're going to obtain a 0 there, and that's what we want. That's wonderful. So let's go about it and see how it will yield the next matrix. Okay, so the rows that are not being affected is the first one. So we're going to keep the entries as they were. It's 1 minus 3, 2, and 0 for the first row. Okay, and on the last row, it's 4, it's 0, 4, minus 1, 3, like that. So the only one that is going to be affected now, we see that it's going to be row 2. So only this one is going to change. So let's apply the operation and see how that is going to be affected. Okay, so now we see that minus 2 times row 1. So we start with the first entry, minus 2 times 1, that is minus 2, then plus 2, that is going to give us a 0 there. Okay, then minus 2 times minus 3, that is going to give us a 6, then minus 1, then that is 5. Then minus 2 times 2, that is minus 4, then minus 4, is it? Yes, minus 2 times 2, that is minus 4, then minus 2, that is going to give us minus 6. Okay, then minus 2 times 0, that is 0, then minus 1. So we remain with minus 1 like that there. So the next thing that we want to do is to obtain a 0 there. Okay, so notice that if you use row 1 with row 3, now when you add them or subtract, this number here is going to change the 0 there. Okay, so you do not want to do that. The best thing to do is to use these 2 that you have obtained so far, such that when you add this and this, it's not going to change any entry. Okay, so we want to obtain a 0 there. The best thing that we can do is here, let's just apply the operation on row 3 in the following way. We can just say this row 3 can multiply it by 5, since we want to obtain a 0 there, and we see that we have a 4 and a 5 there. Okay, so we can multiply row 3 by 5, then subtract 4 times row 2. Okay, 4 times row 2 like that. So 4 times 5, we know it's going to be 20, and 5 times 4 is going to be 20 as well. Okay, and there's a negative, so somehow they're going to cancel each other out. So let's see what we get from that operation. So the ones where we're not applying the operations, they're gonna remain the same. So this row is gonna remain 1 minus 3, 2, and 0. And also the second row is gonna remain 0, 5, minus 6, minus 1. Okay, then yes, the one that is going to change is this one. So we see that we say 5 times row 3. So 5 times 0, that is still going to be a 0 there. And now 5 times 4, that is a 20. Then minus 4 times 5, that is also 20. So it's basically 20 minus 20, then that is 0. I best believe that is simple algebra that everyone is able to follow. I'm not gonna be showing that just to save time, so you can, when you're watching the video, you can pause and try and do those multiplication and addition, stuff like that. I'm basically trying to show you how you perform raw how you transform a matrix or a system of linear equation to raw echelon form using Gauss elimination. Okay, so yeah, I'm not gonna waste much time on those calculations there. So anyway, let's move forward. We say now 5 times negative 1, that is going to give us negative 5. So it's negative 5. Then minus minus 4 times 6. So 4 times 6, that is basically going to be 24. Okay, so it's 4 times negative 6. It's actually times negative 6. So it's minus 5 plus 24. So that basically gives us 19 there. So we have 19 right there. Okay, then now for this 2, we're going to say 3 by 5. That gives us 15. Okay, it gives us 15. Then minus 4 by minus 1. 4 by minus 1, that is going to give us minus 4. So it's basically plus 4. So we get 19. Sorry about that. Then we get 19 again. So we get 19 again also there. So now what is left off for us, we see, oh, we have obtained all the zeros like that. Okay, so what is left off for us is to obtain the diagonal of ones. Okay, so that one is pretty easy and we can do it simultaneously to obtain the diagonals of ones. Already we have one there. Where is short is here and there. Okay, so what we can do to obtain a 1 here is that we can multiply row 2 by 1 over 5. 1 over 5 row 2. And then here we can multiply it by 1 over 19. 1 over 19 row 3. 1 over 19 row 3. So the new matrix that we are going to get from that is going to be, the first row is going to remain as it was, minus 3, 2, and 0. Then when we multiply this row by 1 over 5, here we still get a 0, and here we're going to get 1, and here we're going to get minus 6 over 5. Then here, when we multiply by 1 over 19, it's still 0, 0. Then we obtain a 1 there. Then also here we obtain a 1. Oh, I forgot this side. That's going to be minus 1 over 5, like that. Okay. So notice that when we were taking the coefficients, we're taking the coefficients of x. These are all the coefficients of x. These are all coefficients of y. These are all coefficients of z. So basically what we have there is x, y, and z. Okay, so if it's x, y, z, then we see on this bottom column, on this bottom row, that x is 0 and y is also 0. So z is the one that has a solution there. So z is basically equal to 1. Remember, this line represents an equal sign, so z equals 1. So if z equals 1, then we can further simplify for y right there. Okay, so we see on this second row that y minus 6 over 5z is going to be, so let me write that down, y minus 6 over 5z is going to be equal to minus 1 over 5, like that. Okay, it's going to be equal to minus 1 over 5. So we know that z is 1. So basically y equals minus 1 all over 5 plus 6 over 5. Okay, so this simplifies to 1. It simplifies to 1. So we see that z is 1 and y is 1. So we can use this equation now and say, okay, what is going to be the value of x? What is going to be the value of x? X is going to be x by 1. So that is just going to be x minus 3y plus 2z equals 0. Okay, x minus 3y plus 2z equals 0. Then we know both z and y are, z is 1 and also y is 1. So basically x minus 3 plus 2 is equal to 0. So this implies that x, because minus 3 plus 2 is 1, I mean, it's -1. When we take it to the other side, then x will be equal to 1. So the solution that we have is basically 1, 1, 1. So this type of a solution is consistent. It's actually a unique solution. It's what we call a unique solution because it is only consisting of one solution. There's only one value of x, there's only one value of y, and only one possible value of z. So it's a unique solution, and we call it to be consistent. It's consistent. Okay, so yeah, we're gonna make more videos where we talk about consistent solution, inconsistent, and stuff like that. For now, let's focus on raw echelon form operation. So make sure that if you missed what we were doing on this video, you go back and revisit all the steps so that you can understand how it is done, right? Okay, and thank you very much for watching.